Hey everybody, Adam B. Levine here. Quick question. One of the user-created assets that I'm working on is a charity coin that essentially acts as a global charitable rebate program. Basically, charities have monitored donation addresses, and whenever somebody donates to the charity, they earn a share in a charity token that's distributed to all the people giving to these charities around the world based on how many other people are doing it at the same time. The question is to you, would you be more interested in charitable giving if you were getting back some type of token that could then be used at fundraising events or auctions or things like that, as charities sometimes do, or alternatively could be sold on the market? Leave a comment at forums.ltbcoin.com or leave a comment at letstalkbitcoin.com on episode 104. Back to the show.
So I assume that you've articulated these concerns to the other side of the issue.
I have. They tell me that they're working on a white paper which will address them. But, this is based on what I publicly know.
Well, this is an ongoing discussion, as with all of these proposals, and this is great because that kind of scrutiny allows the problems to be better articulated and to get clarity.
What do you think about the problem they're trying to solve? I mean, what do you think about the concept of sidechains in general? And, do you think that there's a problem to be solved here and this just isn't the way, or that this is just a strange path to go down?
Well, after all, I've got my own competing idea called tree chains, which works differently but has very, very close similarities on a lot of levels as well.
So if we take away the how you do it, underlying this idea of why people are interested in sidechains is essentially the fluid exchange between coins to create a more unified and homogeneous set of currency baskets, essentially, that allow us to ignore the differences between coins on a technical level and use them very fluidly and interchangeably. So you're saying you have a different how for the same why?
Yeah, and I would also go further. I mean, to me, it's not just coins that excite me. It's like new systems of transactions, new systems of auditing, new systems of publishing. I mean, you got to remember, Bitcoin can move value around. Bitcoin can move value around that happens to represent a lot of stuff. But you can also go use Bitcoin to go audit things by going and forcing people to publish results of audits. Mm-hmm. You can do things like make better decentralized publication platforms by ensuring that you actually see what may or may not have been published.
So this is using the full power of decentralized ledger, proof of existence, cryptographic proof of state of systems in a consensus, regardless of currency.
Yeah. And the way I see it is all these systems, because consensus, proof of work consensus is always more secure if it's bigger. The fact is, every single system in this whole space should be working together for security. We should not have 100 different little alt chains with their own little bit of hashing power. That's not secure. We should have all of this stuff working together. Now, sidechains, I think, was an attempt at that, and the merge mining was an attempt at that. But to do that, we also can't go and wreck the security by making things more centralized.
Well, so how does what you're doing accomplish decentralization in a way that they haven't been able to? Or that
you want decentralized unification?
Well, I guess I got to explain tree chains.
Sounds like it.
Yeah.
So I'll actually start by explaining how embedded consensus systems work. And this is your master coin, your counterparty, to a lesser extent your colored coins. And the idea there is, given a set of data that was provably published in some order to some audience, great example is Bitcoin blockchain. Anything in it has some very well-defined order. I know exactly who had it, the mining community, and I can go take that data and then apply my own rules to it.
Yeah.
Mastercoin does this by taking special Bitcoin transactions that have had data encoded into them, extracting that data and saying, okay, we're going to create a new system that has new rules based on top of that.
We've spoken about this before. We talked about the hierarchy of knowledge, which is that the fundamental concept within the blockchain is not only that everyone knows how the rules work, but that everyone knows that everybody else knows how the rules work and applied them in the same way, and that everyone knows that everyone knew that at the time. And those three layers create that shared knowledge. So when you publish something in there, you know that everybody else saw it, that everybody else validated, and that everybody else accepted it as true, which gives you the state at that time.
And see, I claim that those three that those three statements actually are somewhat independent of each other.
Okay.
And I'll give you an interesting thought experiment. Imagine if in Bitcoin miners didn't validate. Any transaction you published, they'd go put in the blockchain. They didn't care what it did.
So it's just a timestamp. It's just a distributed timestamp.
Not
nothing
a
else.
timestamp, a proof of publication.
In the specific order and time.
Yes.
Yeah.
Now, if you're running a full node, obviously your full node can just go through the blockchain, throw away the invalid transactions, and come to consensus. In Bitcoin, using this model is completely secure. And it's interesting that, well, if you have that model, not only is it secure, but I can have two different systems running on top of it, and they're both contributing to the same security. You know, you may want to have standard Bitcoin transactions. I may want to have zero cash transactions.
So this was one of the arguments I heard leveled as a criticism of meta coins like Mastercoin and Counterparty, was that while their transactions have been mined and timestamped and put in order into the blockchain, the clients that mined them didn't validate them. That was criticized as well, that doesn't count. You're saying this is a feature. You're
Yes.
saying we don't even need this for Bitcoin transactions.
Yes.
We can just get the order timestamped and then solve the transaction chaining on a per node basis at a later time once you have an established order that's verified. That's a very interesting perspective.
Going back to what we were talking about SPV, with SPV, you
Sorry,
outsource trust.
hold on one sec.
Yeah, sorry, I think you've lost both Stephanie and I here.
Yeah. So, sorry, we're not very technical. We just want to understand. So, why would you not want somebody to validate a transaction? Like,
So you remember when we were talking about SPV, how with SPV, essentially you're trusting miners to validate for you?
yeah.
And if they lie to you, you're going to trust them and you're going to accept coins that don't actually exist.
Mm-hmm.
Well, what I'm proposing with this client-side validation is really what Bitcoin users already do if they're using Bitcoin in the most secure way, which is to run a full node.
So they validate everything down to the root of the Genesis block.
Yeah.
The difference is that if you expect the miners to validate and you depend on the miners validating, you get a side effect which is rather damaging, and that is that if you want to make a change or if you want to introduce something like Mastercoin, they can't validate it, they don't validate it, they don't include it, so you have no way of doing that later. But if you just have them add everything and all they're doing is recording, then you have the option of how you validate things later at a different layer,
Okay, so
which opens the door for validating a lot
Okay,
more,
I think I
while
understand.
still depending on structured,
So-
ordered recording at the mining.
So the interpretation moves to the individual client side. So each individual user is interpreting for themselves, as opposed to the miners doing it at all. The miners no longer are doing the interpretation; they're just
Right.
doing the recording. So they're notaries, basically.
Let me give you an example.
But
Let's say you were writing a ledger of transactions, and instead of doing it in English, you're doing it in Mandarin, and you have no idea what the transactions say. But what you do is you just write down the Mandarin characters as they come through. You timestamp them, you put your signature next to it. Then you rely on someone who somewhere else gets a copy of this ledger, reads the Chinese, understands the Mandarin, and knows what this transaction means. But more importantly, they see your signature, they know when it got into the ledger, and they know that it was in fact introduced at that time. And you don't even need to understand the Mandarin. All you're doing is validating. You're narrowing the scope. You're no longer validating you understand the transaction. You're simply validating that it existed. You're doing proof of existence only.
Okay, so but doesn't this bring us back to the scalability problems that individuals have running full nodes? I mean, I was speaking with a miner Kimber
I was
meetup
going to
today.
ask a similar question.
Yeah.
Isn't there a cost to doing that notary service to record all the transactions?
Well, no. The notary services, that's carried by the miners. The miners already have that cost. The miners actually do less in this system. The miners just do the notary side. They don't do the verification side. So you can imagine that, Visa has different sections. To this point, miners have been everything. Now we're dividing them into miners over here doing notary and users over here doing actual verification.
And chaining.
But okay,
chaining.
but both of those have costs to them. So what's the incentive to notarize, and what's the incentive to verify the transactions?
Well,
and what's
great
required to
So
do
the
that?
incentive to notarize, in a pragmatic system like this, you would end up in reality having some really, really basic layer to just move a bit of value around. And that's just so you can go pay a miner, look, go publish this for me.
And we already have that. That's Bitcoin, and it works already, so you can do it for the basic Bitcoin transactions.
Now, in terms of the other part of scalability as well, I want to go have an Android wallet. That'd be lovely. I like this. I just want it to be secure. Well, colored coins is a great example of this, because people always say colored coin, it's not SPV compatible, it's not efficient, yada, yada, yada. But hang on a second. If I'm giving you a colored coin, all I actually need to do is prove to you that that coin existed. I don't need to go prove to you that all the other coins exist, or that they're valid, or anything about that. Mm-hmm. You actually just need a very small subset of the total data of the system.
So you're talking about doing validation all the way down to the genesis of the colored coin. So it's not just a partial SPV, but it still ignores all of the other metadata for all of the other things that are going on.
Well, is it even more? I think it's even more specific than that, right? It's like I have some inputs in my wallet, I get some transactions in. The only transactions that my wallet cares to verify are the ones that it thinks it got. Everything else, so you basically trim out 99.99999% because your fraction is the only part that you care about.
How is that different from SPV?
SPV wallets don't bother doing that.
They don't even do that.
Yeah, they don't.
They just depend on...
They could if they wanted to. And if we were in an ecosystem where they were designed to do that, I think we'd be in a much better state than we are.
So let me ask you, one of the criticisms of doing that in a lightweight manner is that I'm assuming that in order to do that, you would need to retrieve a chain, a Merkle tree, that takes you all the way back to the root of that colored coin so you can validate it. And in trying to retrieve that tree, say with a Bloom filter or something like that, you're revealing to the world information. There's a privacy implication here, and there's been a lot of work among the developers here to say, how can you say, I want to learn about this transaction without telling everyone,
hey,
I actually own this coin.
Yes,
exactly.
Well,
right.
So here's an interesting model, and this looks like it'll probably be implemented first on colored coins, is when I go give you some coins, I can go give you that bit of proof. You don't need to go to the rest of the world and get that proof. I can go give you that.
So you transport it so it's self-verifying.
Yes.
Yeah.
And that's actually what we're moving towards with the Bitcoin payment protocol.
That's part of the proposal for smart property too.
Exactly.
From what I remember, it's that you hand the property and the Merkle chain that proves its chain of ownership.
What's a Merkle tree and what's a Bloom? What did you say?
Yeah,
filter.
please.
So a Merkle tree is basically simply describing a path from the current state of the system all through its history, narrowly defined as just the path of those coins as they changed hands, in a way that you can validate it. Mm-hmm. So rather than saying, here's the entire blockchain, here's a tiny branch of it, but it's a branch that walks down just this specific asset that's been transferred.
So it's a map.
A Merkle tree is a data structure, a hash, a tree of hashes, but essentially it's just a map. Exactly. It says, rather than giving you the entire city, I'm going to say, start here, and if you turn left, turn right, turn left, turn right, you're going to end up at the origin of these coins, and now you know they arrived here correctly. And you don't have the full map of the city.
And so even without that, there are no security trade-offs for sacrificing everything but that one path?
Well, I guess I should say, if you have the path for your coins, yes, there are no security trade-offs because you don't care whether or not anyone else's coins were invalid. You just care that your coins were valid.
Mm-hmm. And a Bloom filter is basically, it's almost like a search query, but it's based on probability. So you say, tell me everything you know about this address. But instead of saying this address, instead you provide a data structure that matches it to a probabilistic level. So that way the other person can give you the search results without knowing exactly which address you were asking for. They just know that when you did this search, this result matched at 99%, so it must be one of the things you're interested in, but I don't know what you were interested in. But here it is.
So it's like looking at a neighborhood instead of a specific address or something like that.
Right, exactly. So you go out and say, I'm interested in this zip code. And the zip code is a bit more specific than the entire map, but it's not as specific as a single address. Yeah, that's a great way of describing it. It's like a neighborhood. Of course, it's a much bigger data structure, and it has a much broader range. It's a lot harder to find from the zip code you ask for which address you're at.
Right.
So now that we have this concept of the client-side validation and having subsets, well, I think then the next obvious question is, well, why does it need to be one monolithic block? Can't we, like, split up this block into, like, something a little smaller than an entire megabyte? You know, what if we, say, made the block itself into something more like a tree and let miners work on different parts of this?
No, when you say let miners work on different parts of it, do you mean work on different parts of it simultaneously?
Yes.
Okay, so this is, so you need to have, so you could have multiple blocks going at the same time, each with different transactions included?
So remember when we were talking about merge mining? So imagine you had a system where you had a root blockchain. And it's a linear blockchain, just like one block follows another, follows another. But we'll have a rule where we're allowed to merge mine two blockchains under it, a left and a right.
Like branches.
Yeah. And then we go say, transactions with a unique identifier starting with bits, for the first bit set to 1, are only allowed to be in the left blockchain. And the bits set to 0 are only allowed to be in the right blockchain.
Mm-hmm.
In the top blockchain, any transaction can be in there. Well, we can repeat this rule one step down.
Mm-hmm.
And the prefix that it has to match, that we're restricting where transactions can go, just gets longer and longer.
And it becomes a path.
Yeah.
So do miners select this? Miners choose this? Like, is it a conscious choice to pick a particular branch that you're mining on, and there's more risk reward, or is it just something that happens?
Well, it's absolutely a choice, but it's a choice that's meaningless because transaction IDs are pretty much random.
Could it be chosen? Could it ever be chosen based on something that wasn't random, like mining for like multi-signature transactions in a certain part?
You certainly could, but I think this works best when you just have everyone's contributing equally to the whole thing at random. And the beauty of this is, so if you're a miner and we have this big tree structure for the blocks, now you only need to process the data for one path up the tree. That's a fixed amount of data. It is not the entire system, yet all of our actions together create a much larger system.
So what happens to the block reward in an environment like this?
Well,
because right now block rewards are given, right now 25 bitcoins to a single miner, which is a pool, and then it's distributed up from there. So what does this do?
Is this related to Ghost?
No.
Okay.
No.
But it sounds similar in some ways.
Well, the thing with Ghost is it's about taking blocks that were orphaned. This is about spreading the load up so we're not going to have that problem.
But does it distribute the reward in the same way that Ghost does?
No, what I'm thinking is so if your top blockchain is the full difficulty, you go level down, you can go make each half the difficulty because half the miners are working on one side, half are working on the other. You go level down after that, well now we're into quarters. They're each working on the left chain or the left-right chain and so on.
So because the miners would be specializing more, then they would be able to mine at lower difficulty and it would decentralize mining more?
But it's like random specialization, right?
Yes.
Yeah.
Yes. But if we all work together randomly working on bits, the sum total is that we still move the blockchain forward. Mm-hmm. And yet, if I've got, say, a gigahash of mining power, well, I'm still going to find a reasonable number of blocks, say 5 levels down or 4 levels down. I'll occasionally find blocks 3 levels down, even less often 2 levels, and sometimes I'll even go find the top block. And if the reward is split across those, and decreasing amount, on average I still end up making a reasonable return, and my variance is low. So I can mine profitably without involving a centralized pool, and I'm also contributing equally to the security of this entire system.
How deep can the tree go?
As deep as you want it to go.
So in that case, I could be solo mining 64 levels down and still have a possibility of getting some. So the pool is now part of the data structure rather than part of a protocol.
Yes.
Essentially, it's expressed as a distribution within the data structure rather than a distribution of nodes on the network.
Yeah. And the other way to think about it, too, is that this is giving you a trade-off between security and scalability. Sometimes you need to go publish data to the entire world. You know, if you're moving a lot of money, you can go pay a bit of fees, and you want this to be absolutely secure. Conversely, at some point, obviously you're going to get to a point where there's only one miner actually mining some chain like 12 levels deep, 16 levels deep, whatever it takes. And that's not going to be secure in the same way that eventually an altcoin isn't secure. But there's a catch. Unlike an altcoin, you can then go say, well, the rule is, if this block up here gets reorganized and its children, or sorry, I should say, so if a block gets reorganized, you can say its children also get reorganized, which means that now, even though not the whole system saw some block, say 16 levels deep, the time ordering is still secured by the whole system, which means if I want to accept payment from a block that's not very secure in of itself, I can just wait till its influence kind of propagates up and it can't be reorganized out, and then ensure that, well, when those coins got spent, there's no way they're going to be unspent without a much more difficult block getting reorganized, and so I can recreate them.
So even if it's included in a really low level, insecure block like 16 levels deep, because it eventually migrates up, because it's part of the bigger picture.
Yeah.
It over time, as blocks further up are found, it'll be included and essentially confirmed into existence, even though at the beginning it's unsafe.
Yeah. And if I have proof going back in time, well, I can go give you the proof that yes, those coins really were securely moved to that chain, they were not attacked. You can now trust this, and you can then give that proof to someone else.